This is another example for college algebra for partial fractions. So we have this fraction, a rational expression with x's in the denominator, and we need to figure out what two fractions were added together to get that result. And that is called partial fraction decomposition. So we need to first write out the factors. So let's look at the denominator. I don't see anything that needs to be factored. It's already factored. So I would say the factors of this fraction, or factors of the denominator, sorry, are x minus 9 and x plus 2. So that means we're going to have two fractions for an answer. So my first step that I tell people to do is to write this in one big equation using a, b, c, d, a bunch of constants up in the numerator of the potential fractions. And actually, they don't have to be constants. They could be coefficients. So we're going to have two fractions for a result, and one of them has x minus 9 in the denominator, and one has x plus 2 in the denominator. And up top, I'm just going to write a and b. And the reason why I just write a, just write b, is because this is a linear expression, and so you take it down one power, and so a would be kind of like an x to the 0 power. But don't worry about that. Right now, let's just worry about being able to write a over over a factor and b over a factor. Next step, we get rid of the fractions. So multiply the entire equation by the two factors. And it gets rid of the fractions. Cleans it up a little bit. So on the left side, all the factors disappear and we're left with 3x plus 50. On the right side, that first fraction, the x minus 9 cancels out, and we have a x plus 2. And then for the next, the x plus 2's cancel out, and we have b x minus 9. So first step, write it in one giant equation. Next step, get rid of the fractions. Next step, simplify. So 3x plus 50 is ax plus 2a. I like to write the numbers in front of the a's and the b's. And then we have bx minus 9b. All right, last step. Create a system and solve the system. So if you need to, make a mark on like terms. So we have the x terms right here. And that creates an equation in a system. So we're going to just take the coefficients and say 3 equals a plus b. Then make a mark on the leftovers. Really, there's only one set of leftovers, the constants. We have a 50, we have a 2a, and a negative 9b. And that creates another equation. Whoops, that's a minus. All right, now we want to get these to cancel out, or we want to get one of the variables to cancel out so we can solve. So I'm going to multiply the top equation by, or let's go sideways, by negative 2, so the a's can cancel out. And you can do this step in your head if you want. We end up with negative 6 equals negative 2a minus 2b. And then I'm going to add that resulting equation to my second equation. And the a's cancel out. So we have 44 equals negative 11b, and b is negative 4. And then we're practically done. Plug negative 4 into either of the original equations. I'm going to plug it into the first. 3 equals a, and plug in negative 4 for b. So a is 7. Let's plug it back into those two fractions at the top. So final answer, 7 over x minus 9 plus negative 4 over x plus 2. And that is partial fraction decomposition. Hope that made sense.